Hello, once more. Welcome back to the desk. In this episode, what we're going to do is we're going to take this little beastie, which we built in the previous episode, and we're going to add a little bit more functionality to it. This is, as just a quick refresher, this is an 80Tiny85 DCC function decoder. We've got a little power LED. We have DCC inputs. We've got a bridge rectifier. This 10k resistor and the diode form the input circuit. We have a power supply with an LM7805. A couple of capacitors that smooths that. That gives us a 5 volt supply on this board. And over here we've got four LEDs, each with a 150 ohm resistor. If we just have a little look, we can bring the circuit up. And what we've got on here, very, very simply, is 4 LEDs that act as our function outputs. As the screen says, outputs chosen. Okay, you can change whatever colours you like, but you want at least 60 milliamps when they're all on full. And that's what we did. And what we're going to do today is I'm going to turn this into a slightly different circuit. So just bring the circuit back up again. We're going to modify it into this circuit here. Now, the left-hand side is the same. The only thing I've changed is the output side. Now, I'm going to move away from making the lights flicker. As we saw, when we program this thing, all 4 of these lights come on and they flicker, and they're quite bright. 150 ohm LEDs, these have got about, there's not quite 20 milliamps going through each, but it's about that. They come on quite brightly, much, much more brightly than this red LED down here. Don't really want that. So what I'm going to do is I'm going to sacrifice this blue LED, and I'm instead going to put in, back to the pictures here, this 180R resistor, so 180 ohm resistor. This is on the 13 volt supply. That is going to give us, I hope, enough current that we can just switch on and off. Now this is going to be through a transistor, basically because this little 80Tiny can't handle 13 volts, so I'm going to just switch it through a transistor. We're not going to change any code, not initially. So I'm going to build this circuit and then we'll talk you through it. So I'll be back in a mo. Okay, back. So I have built this, so let's have a little look, and here we go. Slightly out of focus. Zoom up here a little bit. Yeah, anyway, this camera has manual focus. It's a little bit awkward to use. Right, so what have we got? We've got a bunch of jumper wires which are just getting in the way. If I move those over there a little bit. 4 transistors, each which has got its 1k base resistor. This one here has got its... we've got here the power unit, so this is the programming feedback resistor. It's actually... the resistor is technically a little bit too small. Not resistance, the resistance value is fine. It's only a 1/4 watt resistor. It's getting about 0.7 of a watt through it, briefly, so it should work. We'll see how warm it gets. I don't have any larger resistors. I didn't fancy spending ages putting a load of them together. So anyway, we'll see how that goes. Yellow LED with the yellow wire here is F1, and then here we have the 2 channels for F0. I did have to make a couple of slight code changes. I didn't think I was going to have to, but I did. So what we're going to look at here, nope, that one. There we go. Click the right button. So over here, I changed the name of the F2 pin to be load pin, just to clarify things a little bit. I've removed the code for F1 state because F2 state because F2 is no longer doing anything. And the bit I had to change was, where are we? Down here in the notify acknowledge. It now just toggles that one pin instead of toggling all of them. Essentially, I wanted to make sure just that one bit of circuit worked. I've changed some of the other names and I've set these up so that they start up in the low position. and then I've removed the bit down here for F2. So what we're going to do now is we're going to go down to the cellar, and we are going to have a little look at, where are we? This thing working, I hope. To the cellar. Okay, here we are down in the cellar. As usual on the programming track with stuff jammed underneath. So if I turn the power on, power light comes on, no other lights come on, which is what we'd expect. What we've got, two groups of 3 white LEDs, as per the diagram, 1K resistor. These are your interior lights. There's a red LED here, which is your tail light, and there's a yellow one, which is function 1. The first thing we're going to do is see if this programming thing works and see whether I can get JMRI to detect this. So if I just release that, I was hoping. Identify. And we see the text down here. It is reading things. There are no flashes. There's no smoke coming out of the thing up there, so that works. So it's identified that nicely. Bring up a throttle. Back into running mode. So let's have a look. F1. On, off. That works. Main lights. So there's your interior lights. There's your reverse light. Interior lights. And off. And on. Tail light. And off. And for some reason, the tail light won't switch off. There's obviously a code problem there somewhere. I need to look at that. Now, there is a slight flaw here. Obviously, you don't really want your coach lighting to be directionally dependent. So I need to go and do a little bit of code changing. We're going to make those lights directionally dependent, and we're going to make them not quite so bright, because that'll probably be quite useful as well. So, with that little experiment done, back to the desk. Right, so that works. We just jump back to the circuit diagram. That's working. Sort of. Let's just work out why that tail light's not switching off, which is GPIO 1. Yeah, so let's have a little look, see what we can come up with. So, GPIO 1 should switch off. Down here, it's one of these. Let's go in and change some of these definitions here. So the interior lights are on pin 0. Well, GPIO 0, which is physically pin 5, which is, I'm just checking this here. Yep, that is correct. So that is my interior lights. So I'm actually going to change that definition. I'm going to call that interior pin. I'm just going to go down here and I'm going to find where that starts, which is interior pin, interior pin. I'm going to come down here. Now, I need to change some of those codes there. So what we're going to do, I'm going to change another definition up here, and I'm going to change that one as tail pin. Because this is our tail light. So again, let's just come down here and change some of these bits. So that one becomes tail pin, that becomes tail pin. Right, and what I now need to do is modify down here. So if we're in forwards, the tail light is going to be on. There is a reason for that. And then I can just get rid of these. The idea behind this is, this thing is effectively the tail light on the back of the coach. So if the locomotive is going forwards, I want the light at the back of the coach to be on. it's, yeah, you could do it either way around. So now that should mean the headlight only does that, and it should be directional on and off. So what I need to do now is work out what is going to control the interior lights. And I'm actually going to rename that. I'm going to call it F2 for the simple reason I'm going to use function 2 to turn the interior lights on and off. So if I do that, basically I shouldn't have got rid of the function 2 code. Anyway, never mind, I'll come back to that in a minute. Where do we go down here? Interior pin becomes F2 pin, F2 pin, like that. So I need to redo that. Back to down here. In fact, actually, there's an easier way of doing that. What I'm going to do is I'm going to copy that from the previous example where it worked, because that way I don't have to mess around with anything. So I'll just go there and just do that. We're going to come back to that in a minute, because I don't actually want that to work in quite that way. So what I now need is to get function 2 working again, because obviously I disabled that, so I need to come up here. Where are we? That goes in there, which is set the state of F2, so I'll put that back in. Set the state of F2, and I need to put the F2 variables back in, which I took out because I'm a moron. Anyway, so that goes there. So that should now work. What we're going to have is we have directional lighting for the headlight bits, and then these other two down here. However, as I said, we don't really want to do these in quite this way, so I'm going to change this slightly. So we're going to go in if and new F1 state, because this is the brake light. We're going to do something else. We're going to do something else. Now, I could, out of the way, just put this in here like this. So I'll do that. And then here, I'll do that. Now, at the moment, that's going to do exactly the same. We can have a little look at that in a sec. Because what I'm now going to do is go copy that. Paste it there. I'm going to change that to be F2. I'm going to change that to F2. I'm going to change that to F2. Change that to F2 and change that to F2. So I'm just going to hit verify, because this will tell me if I've really made a mess of that. No, that'll work. So there we are. Now remember, I said I want to control the brightness of this thing. So this is where we can control this here. So when the lights are off, very, very simple. We'll turn the lights off. Lights are guaranteed to be off. What I'm actually going to do here, though, is use our friend from before, if you remember this. The two pins these are on can do this, which is why I've chosen these lights to be on these pins. What intensity should you do the tail light on? 128. Let's do that. Except obviously I've just put that in completely the wrong place. That needs to go from there to there. Turn that off and do that. Yeah, anyway, right. And what we're then going to do is the same down here. Going to do that. Going to turn that off. And those coach lights were quite bright, so I'm going to turn them down to 1/4 brightness. That should work. So that's that. Now, what we're not doing as yet is responding to various CV values, which would be useful things to do. But Anyway, I'm going to program that. We're going to go downstairs again and we're going to see if it works. And I'm going to see whether the tail light thing actually does what it's supposed to do. So I'm going to program that. I'll catch you again in the cellar. So here we are back in the cellar. So first we need to do is turn the power on. So power light comes on. Function 1, yellow light still working. Function 2 is the interior lights which come on, and they're no longer as blinding as they were, which is quite nice. So turn those off, and then we're in forwards, we're in reverse, we're in forwards. So that, and the weird behaviour I had before where the light wouldn't switch itself off. Let's try again. Yep, and try it that way. Yeah, the tail light is now turning itself on and off as it should do. And again, its brightness is reduced. It's still reasonably bright. I mean, you can sort of see it compared to the other light, but it's on a different power setting. So there we go. So with that, switch off. Once more, back to the desk. Okay, we're back. Now that worked. Now what would be useful, I'd be just better, is if we could define those brightness states and do something with them. So that's what I'm going to do. And we're going to do something nice with these in a little bit. So tail brightness, and I'm going to give that a very low value by default. And you'll see why in a minute, because I want to see if it's actually working properly. Interior brightness, also a low value. And what I'm going to do is I'm going to go right down to the bottom. Where we write this thing here. Yeah, cool. I didn't actually do it that way. Right, I'm going to want a third one. So let's have a little look on here. No, I don't need that. Right. Let me just do the interior brightness bit. I made a slight boo-boo last time. So F2 is our interior lights. So that is going to go there. I'm just going to make a little note on here that is interior lights. This one here actually probably won't do anything because it's not a PWM enabled pin, I don't believe. So that I'm just going to put back to as it was. But actually I can even go back to the even easier version of that. I'll just delete all of that and just do that. So there we go. So F1 is the yellow LED, which will either be on or off. Interior lights will pick up the brightness. What we now need to do is set up the brightness on the tail lights. So that is going to go there. I'm going to set that to be that bit. I'm going to set that to be tail brightness. And if it's off, we can just write 0 and it'll be off. And that'll work, or it should work, assuming I haven't made a mess of anything else. But wouldn't it be useful to put those two values into CVs and be able to program them directly so I don't have to bother rewriting this stuff? I think that'd be quite a useful thing to be able to do. So what we're going to need to do is define ourselves a couple of CVs. Now there are all sorts of standard ones of these things. But the beauty of this is when you're making your own decoder, you get to decide whatever you want to do. So I'm going to use the user IDs. Use the two user ID fields. Essentially because they're easy to change in JMRI, which is why I want to do that. So that's what I'm going to go with. And I'm going to make a note of what each one is going to do. So that is going to be interior light brightness. And that is going to be tail light brightness. There we are. I managed to tick caps lock while I was doing that, which I didn't want to, so I shall do it that way. Tail light brightness. Okay, so now what we need to do is define the values in here. So we're going to come into here, and these are the factory default values that I wish to set. I can set these to be anything I like. So I'm going to come down here, I'm going to go into that, I'm going to say that one, and that is going to set to 128. And then I'm going to do that one, which is 6, like that, comma, 128. Don't want that there. The reason for doing them as 128 is so they're different to those other default values. And obviously when we first run this, it's not going to know what they are unless there's something in the chip already. So there's two more bits I need to do. One is when we start up here, we want to read what those values are. So I need to remember what I called the things. So where are we? So interior brightness first. So interior brightness. And this is because if we don't do this, we've got no idea what these things are called. DCC, and this function here is called get CV. And I give it the CV value I want. And the CV for the interior brightness is, the pop-up out of the way, that one. So we scroll back down here to where that code is, and we do that one. And then I'm going to go tail brightness equals dcc.getCV. And you can use this to read any of the CV values, which is quite useful. So you can store anything you like in this. This goes into the EEPROM on the thing, so you're limited to how high a number you can go with. So that'll read the initial values. Now there's something else we need to do, because that, at the moment, if I change those values, it won't do anything until I restart and reset the decoder. I don't really want to do that, so I'm going to come into here. So have we got the appropriate function defined? We should have here. Here we are. Notify CV change. Now this is going to tell us a CV value and a value. So what we're going to do is, when I can type it correctly, we're going to use a switch statement on the CV. That comes through as a number, so we can do this. Switch just saves you having an awful lot of nested if statements. So case that, if it's that, what are we going to do? And you have to put this break line in here, because if you don't, it doesn't work. I'm going to go there, and I'm going to go case that one. I'm going to change that in a sec to be the other value. And that's that. And that goes back to that one. Now you could give these slightly better, slightly more descriptive names, which actually wouldn't have been a bad idea. So 105 is the interior brightness. So that goes into there, which is that one, equals value. And what this means is, if you put this on the programming track and tell it I want a different value, this should pick it up without everything breaking off. And that's that. Now, in theory, that should work. So again, I'm going to program this. We're going to go down to the cellar and we're going to see if it works. So, to the cellar. So, here we are back in the cellar. Now, let's have a little look. So again, if I turn the track power on, it was in programming mode. Incidentally, whenever I flick from normal to programming mode, I'm actually resetting the decoder. If you watch the power light, the way I've wired this, it actually cuts the power. So we're in programming mode now. So what I'm going to do is kill the throttle, because I don't need that. Tell identify. So again, it reads everything we've got nicely. There we are, going to program. Now what I now can do is look on here. Now these user ID fields, These are where I have told it to store the brightness settings. So they're on 128, 128, which, if you remember, is the factory default setting. So that's not the really low 32 value I set as the default in the code. So that's there. So now I'm going to do, save and close those changes. Run mode. I'm going to bring up a throttle, which is set for number 3. I'm going to turn the headlights on. We're in forwards, we're in reverse. Reasonably bright. Yellow still works. And then F2. Coat lights. Now they're quite bright. So let's reprogram them to be a bit dimmer. So I shall close the throttle. Back into programming mode. I'm going to try something in a minute. Anyway, program. I'm going to try the programming on the main function and see if it works. So here we are again. Read this sheet. Goes through like that. Let's make these really dim. 32, 32. That should do. And enter that. Right. Write those 2 changes. Get out of that. Save and close. Back into main. Bring up a throttle again. It's a little bit convoluted. Right. Headlight. Seems to be working. And now you'll notice the interior lights are much dimmer. The red light seems to be a bit dimmer. I'm just going to... Yeah, that one should be on pulse width, so it should be dimmer. It might not be, I might have got something wired wrong. But anyway, the main lights are working. So what I'm now going to do, I'm going to set this to program on the main. Now I can't read values anymore here, but I'm going to go 255 and I'm going to see whether one of these goes. So write the changes. I don't know whether that's working. I'm going to set the other one to 255. That may or may not be working. Let me just reset that. And now it's picking it up. This means I've got an error in the acknowledgement code somewhere. But what you can see is, if I set that one to be 16, set one of them to be really, really dim. So write that and then reset. You can see they're much dimmer. I'm going to try that red one again and just see if that goes dimmer as well. And this is programming on the main. Now this is potentially quite useful. Yes, I don't think I've got the analog right on the tail light working correctly. But anyway, but what we've got here on this screen here is the ability. I think it's that one. Write changes on sheet and turn off, turn back on. To store brightness values. To put back down to something a bit more sensible. 32 should do it. I'm quite pleased with this. Yeah, we've got the ability to store off, back on, much dimmer. We're now storing CV values and using those CV values to do things. So, as you see here, if I want to change the brightness of those lights, I don't have to reload the code. And the best bit is I can do it on the main, so I can play around with it. There's some other bits I want to do with that, but for now we're going to go back upstairs. We're going to have a little look at the code. I'll show you the slightly corrected version because I had to correct a couple of typos. I'm going to see if I can work out why that acknowledgement function isn't working. And then we'll have a talk about what we're doing and what's going to happen next. Anyway, to the desk. Okie dokie, back at the desk. Right, first off, the typos. I had semicolons in here and they should have been commas. That's it. That worked. Notify CV change doesn't seem to be fully working. I need to have a little bit more of a think about that one. However, the code for writing the brightness seems to work quite nicely. Yeah, I need to analog right interior brightness, analog right tail brightness. It's turning it on, it's turning it off. I need to have a look and see why the whether I've got actual separate brightness control over that or not. But overall, where are we? Well, go back to this. This is where we now sit. We have moved the LEDs off the 5-volt supply. So they no longer are being driven by the LM7805, which has reduced the current load on that. That is now literally driving a power indicator LED with about 3 milliamps. It is driving the AT Tiny, which doesn't take very much, and a couple of 1K resistor outputs, which is again a few milliamps to drive a couple of transistors. That's it. The rest comes off the 13-volt supply, which is fine. So we've got the yellow LED, which is function 2, the red LED, which is the tail light, and I need to make sure I can use the PWM function on that properly. And then the interior lights. Now these are split into 2 strings of 3, each with their own resistor, basically because I can't run 6 of them on a single pulse width output. And the reason I want that, if I just go back to the camera, wherever it is. Where's me? Which one? I need to see which one's my camera. Oh yeah, webcam only. Here we go. The reason this particular one wants 6, it's eventually going in this. So we've got 1, 2, 3, 4, 5 compartments and a guards compartment. So I want 6 lights. That's where the 6 lights comes from. You could vary that quite happily. All you need to do is make sure your power supply can drive however many LEDs you can put in series and set a suitable resistor. And what else have we got? Well, we go back to the code, if I can work out which one I need to use to get to the code. Here we are, and we are storing CV values. So we're storing a brightness in CVs 105 and 106. Like I say, I picked those because, as you saw with the JMRI screen, they're quite easy to get at and quite easy to change. You can store them elsewhere and you can use different functions. I mean, you can define any CV to be anything you want. JMRI's Decoder Pro sort of expects certain values to be doing certain things. So there you go. And that's that. So we're, pulse width output, user programmable. I'm going to come back to this. I'm going to be doing a little bit more code with it. I'm going to experiment more whether I can do the actual brightness and get that working on the red tail light. It may well be a case that it is actually dimming. It's just not dimming particularly noticeably. So I just need to do a little bit more experimentation with that. We're going to look at setting up so we recognise the direction from CV 29. And the big one I'm going to do is actually going to be using another function. I'm going to say I want to be able to say to this rake of coaches, you are connected to a specific locomotive, and therefore pick up its command for direction, as well as setting their own, so that effectively you can couple this to a loco and have the taillights work. And to do this, what I'm going to do is I'm going to hook up both of these things as with their own little boards. I've got a prototype one of these I did before I did this series, which has a LED board that looks a little bit different. But what I'm thinking is I can set both of them up to make it look like I've got a coach, a couple of coaches behind the train, and away we go. So with that, I will leave that. The code and the circuit diagram, as usual, is going to be on GitHub. And open to comments. I'm aware, I need to make that programming resistor a little bit larger. This one works, but at best practice, you don't want to overload it. Normal decoders would use the motor. Obviously, I haven't got one, so I need to put a slightly bigger resistor in. And that's that. Ideas, etc., more than welcome. So with that, I will leave you to the rest of your week. Thank you very much, and goodbye.